Scientists' new terrifying discovery at CERN changes everything. The scientific method is an effective method of worldwide inquiry that has made it possible for everyone to use things like electricity and space travel. For example, the Big Bang Theory, which says that the universe began with a single, huge explosion, needs more rigorous analysis. Researchers do experimental studies and build huge research centers to find out more about the world. Hello everyone, welcome back to the channel. Please make sure to subscribe to the channel and press the bell icon to get all the new notifications from the channel. The Large Hadron Collider becomes a valuable part of the debate about the Big Bang. The LHC still has the support of scientists from all over the world, but because it is so big, it uses a significant amount of energy. Yet despite this consideration, research nations are behind the project because of its important role in improving our knowledge of the universe. And lately, it discovered something that some consider frightening compared to other particle accelerators. The LHC is both the largest and most powerful machine of its kind. It is in Switzerland at a place called CERN, which is the European Laboratory for Particle Physics. After 3 years of improvements and upkeep, the LHC returned to work on April 22, 2022. It started its third attempt on July 5th, just 1 day after the 10th anniversary of when Higgs boson was found. In the field of particle physics, the Large Hadron Collider is used to test the Standard Model. There are still some mysteries in particle physics that the Standard Model can't solve, like dark matter and dark energy. The LHC was made to help figure out things like why the matter is more common than antimatter. And because of the massive accelerator, researchers can smash high-energy subatomic particles together and study them in a monitored lab setting. The most well-known thing it did was to find the Higgs boson in 2012, but that wasn't the end of what was found. For example, in January 2022, researchers at CERN said they had discovered proof of X particles in the quark-gluon plasma made by the Large Hadron Collider. This technical language hides the mind-blowing truth that CERN has recreated a situation that hasn't been seen in nature since the first few microseconds just after the Big Bang. And there will soon be a lot of breakthroughs. The LHC is a particle accelerator, which indicates that it accelerates subatomic particles to very high speeds in a manageable manner so researchers can investigate how they interact. It is the largest accelerator that has ever been made. It fills a tube that is more than 17 miles around. Large Hadron Collider is the name for it, since the particles it analyzes that we may recognize has protons but are actually composed of tiny particles called quarks to fall underneath the hadron umbrella. Since the LHC, particle beams moving in opposite directions are sped up. When these beams touch, something happens. Even though it might seem strange, scientists are eager to discover holes in the basic physics model to begin explaining things like dark energy and dark matter. After 3 years of maintenance, the LHC has been changed so that it can now collide protons. The latest vertex locator, or VELO, was partly built in Manchester. It increases performance and makes proton collision happen more often. One of the 4 main experiments, LHC-B, has been updated with new detectors and a new way to interpret the information. This lets it work at 5 times faster collision rate and makes it easier to choose the right information. Professor Parks from Manchester University said that the project is important and that closing the new LHC-B vertex locator is a big step toward improving the experiment. Once the new LHC-B vertex locator is shut, LHC beams with the energy of the Eurostar train will pass through a hole the width of a pencil. Because the sensors are close to the LHC beam, they will be able to take very clear pictures of the LHC collision. The module that finds the vertex cost £50 million. Professor Parks was in charge of building it, and the Science and Technology Facilities Council paid for it. For 10 years, people have been working on making the experiment better. In 2007, preliminary talks began. Over 80% of the vertex locator modules were made in the clean rooms of the Particle Physics Group in the Department of Physics and Astronomy at Manchester University. Before such modules might be delivered, the scientists, technicians, engineers, and students who performed on them ran into many problems, such as glues that didn't work as planned and a research center that was locked at the start of COVID-19. Components were bought and bonded to 0.5 millimeter thick silicon material, which will be the major plate that holds the other parts, as well as cooling the area so work on the module can begin. The tiny channels are cut into a silicon plate and filled with liquid carbon dioxide to get rid of the heat made from the sensors and readout circuits. The front-end readout circuit and pre-made silicon pixel sensors connected to the readout chips were then attached to the silicon substrate. This made 6 cm square rectangular parts. After hundreds of small wire bonds were used to create electrical interconnection, and all power and information were connected without wires, modules were tested in a vacuum environment that was the same as their final LHC setting. To put this module together and test it, you need special tools. Technicians and physicists work together to develop the technology and materials required to make detectors that work in a high vacuum and track the position of particles with a precision of about 10 micrometers. These sensors have particular functional requirements used to develop the technology and materials. All parts must be able to withstand radiation because particles hit them so often. The head of the LHCb team of the University of Manchester, Professor Marco Gerstner-Beck, said, "Our team of physicists, engineers, technicians, and students use their skill and knowledge to design and build most of the high-precision detector modules that make up the Velo detector over the course of a decade. The very first full operation marks the end of this project. The rest of the Velo team was in the trenches at CERN, working hard. They checked the data's accuracy in real time and set the positions of all detectors on any Velo components to within a millimeter of accuracy. In the years ahead, researchers will research how radiation affects the performance of detectors, and over the next 10 years, LHCb dataset is anticipated to expand by a factor of 6. New sources of antimatter and matter asymmetry and a new particle are just two of the many important discoveries made by the LHCb experiment, which is devoted to the exact research of core-containing particles. The new Velo modules can record 30 million collisions per second, which means that they will give very accurate results over a lifetime. The University of Manchester team can now work on making the next generation of particle detectors that the new ones are up and running. This project was made possible by a £49.4 million UCRI infrastructure fund, will make the NHC more accurate and give it new challenges that will change its ability to find things in the big way. So, what do you think about the LHC and the things it has found? Please tell us what you think in the comments. And if you like this video, please give it a thumbs up and subscribe for more. Click the bell icon to see what's happening in the channel at any time. And thanks for watching. We'll see you next time.